Okay, so let's start our today's class. Okay, so hello everyone. This is lecture 7 on discrete mathematics. So in the previous lecture, we have started Mississippi problem, and I have told you it is a trademark problem for permutation with limited repetition. Let me write it. It is a trademark problem. Okay. Trademark means whenever I will say Mississippi, you will immediately link it with permutation with limited repetition. Okay, and I have solved many questions on this. Okay, so I think you already remember. Yeah, so last question was this. Okay, probability that we pick a word at random from all jumble words of Mississippi and it start with B. Okay, so yeah, we have done it. So now let me start our today's class. So we have five identical maths book, three identical physics book, four identical English book. How many ways we can arrange them on shelf? So the basic thing is we have five identical. Okay, so total how many books are there? 5 plus 3, 8 plus 4, 12. So we will write 12 factorial. And what are the you can say uh, copy or identical things? 5, 3 and 4. So 5 factorial, 3 factorial, 4 factorial. This is my answer, just like Mississippi problem only. Okay, yes, so please take snapshot. I will jump to the next slide. So you have to concentrate on this word identical in the gate exam. Okay, then you have to answer this question. Let me jump to the next slide now. So this is very important point. Make some stars over it. You will get confused in gate exam. By default, you have to take every subject as different. For example, if identical word was not there and they have said 5 maths book, then you will consider all these maths book to be different. Like you can consider one of them as algebra, another another can be linear algebra, third can be calculus, and so on. Okay, so like this. So 5 maths book. So one algebra, linear algebra, calculus, and so on. Okay, so like this you have to consider. So if nothing is given, you will take each and every object to be different. So when they ask or when they properly mention identical word in gate exam, only then you will say identical. Only then you will consider them as identical. Otherwise, you will never consider them as identical. Okay. So for example, if question came 5 maths book, 3 English book, 4 physics book, how many ways to arrange them? Simply, you will simply say 11, sorry, yeah, 12 factorial. That is my answer. Okay. So in gate exam, simply you will say 12 factorial is the answer. But in previous slide, answer was 12 factorial divided by 5, 3 and 4 factorial. Why? Because word identical was given. And since here no identical word is given, so we will consider all these maths books to be different books like algebra, linear algebra, calculus, and so on. So answer will be straight away 12 factorial. Okay, please try to remember this kind of things. This type of things have been asked repetitively in gate exam. Okay, so this has been asked repetitively. So you have to, you can say, remember this thing. Okay, yes. Now please take snapshot. I will jump to the next slide now. Okay. Yes. So now I'm jumping to the next slide now. Okay, so next is 5 identical green flags, 4 identical red flags, 3 identical blue flags. How many ways to arrange them in a straight line? Very simple. 5 plus 4, 9 plus 3, 12. So 12 factorial. If they are different, then 12 factorial is the answer. But still, since some of them are identical, so 5 factorial, 4 factorial, 3 factorial. Then that's it. Okay. Yes, please take snapshot. I will jump to the next slide. Okay, I'm jumping now. Next is 5 is 3 B's and 3 C. So we call this as a multi-set. Okay, in a set, a repetition is not allowed. Like this is a set. But if I say double A, B, C, this is a multi-set. Okay, this is a set, but this is a multi-set. Multi-set means set in which we have repetitions. Okay, that is a multi-set. So now this multi-set is given and they are asking how many words are possible. So I have not written complete question, but I think you have got the idea. So how many words, how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 letters are there. So they will say how many 10 letter words are possible. Okay. So words 10 letter. Words of 10 letter are possible. 10 letters. So obviously we will consider them. So what will be the answer? So assuming all these are different, so 10 factorial, so divided by 5 factorial, 3 factorial, 2 factorial, this is the answer. So it's just like Mississippi, na? So we have say 1m, 4 i's, okay, and then 4s and 2p. So how many jumble words? Okay, so it is just like Mississippi problem only. Okay, so answer is this 10 factorial divided by 5 factorial, 3 factorial, 2 factorial. Okay, please take snapshot. I will jump to the next slide. Okay, so I hope you have taken it. I'm jumping to the next slide now. So next is, so now I will mingle up the questions. Okay, so I will apply constraints on all the three categories. What are the three categories we are doing? Permutation without repetition, permutation with limited repetition, permutation with unlimited repetition. So all the three categories now I will mingle up and I will ask questions regarding some constraints. Constraints means some restriction we will apply. Okay, so let me jump to the next slide now. Please take snapshot. Please be active. Once you are done, please let me know so that I can shift to the slide on a very faster manner, and this will save our time.
Yes, sir. Yes, sir. It's done, sir.
Okay. Next is the first type of constraint is starting and ending. Like what for example, I say 4-digit even numbers. Okay, so how many 4-digit even numbers are possible? That is the question. Okay, this type of question I've been asked in GATE many times. So even numbers. So by default, obviously we will take repetition into the consideration. Why? Because see, 2 this is a 4-digit number. Who is saying that this is not a 4-digit number? This is now. So obviously we will consider unlimited repetition. Okay, yes, so this is the way you will identify this in GATE exam. Okay, so 4-digit numbers. So let me draw the box method. This is the best method, I have told you many times. So even numbers. So what are the possibility here? 0, 2, 4, 6 and 8. Last place 5 possibilities are there. Okay, yes, and at the first place, since it is a 4-digit number, you cannot have 0, because if you give 0, then obviously it will become a 3-digit number. So I cannot have 0 here. Okay, so obviously what are the possibility here? 9 possibilities are here, because 0 is not allowed. Okay, and then here how many possibilities are there? Obviously 10 possibilities. 0 to 9 you can take anything, 0 to 9 again you can take anything, and here 5 possibilities. So what is the answer? 9 into 10 into 10 into 5. Are you getting it now? Why there are 10 possibilities? 0 to 9. Okay, you can take any digit. Okay, so final answer is 9 into 10 into 10 into 5. This is my answer. Next is 4-digit odd number. 4-digit odd number, same scenario. I think you have got it. Same. So I should not repeat it again and again. You will copy paste it. Let me copy it. Okay, same thing. The only difference will be, okay, so what will be the difference? Let me take it. Yes. Yeah, so the difference will be here 13579. That's it. Odd na. So 13579. Okay, so same 9 10 10 5. Okay, so yeah, so now you can take snapshot.
Done, sir.
Okay, yes, so the next is 4-digit even number without repetition. This is important. So now we want to have 4-digit even number without repetition. Repetition is not allowed now. So how we will do it? Same box method. Okay, yes, so now at the first place 0 is not allowed, and at the last place what are the possibilities? 0 2 4 6 and 8. Okay, so now uh, we have to you can say deal such kind of question very carefully in GATE exam. Okay, so because there is no repetition at all, so how we should approach? So see this. So I will say like this. See, since this is a 4-digit number, so and at the last place we can have 0 to 468. So 0 is allowed here and 0 is not allowed here, so that will create problem for us. So first I will say that it is ending with 0. It is an even number and it can end with 0. Now since it can end with 0 and repetition is not allowed, so I will say here how many possibilities are there? I think you have got it, 9 possibilities. Okay, from 0 to 9, 0 to 9, total 10 numbers are there. Repetition is not allowed. So here 0 is there, so 1 possibility. Let me write it properly, otherwise you will get confused. So here if I consider 0, then here I will be having, I am not writing here, I will write it here, 9 possibility, and here 1 possibility. Okay, yes. So now one number will be consumed here. So how many possibilities are here? 8, and here 7. So obviously what will be the answer? 9 8 9 into 8 into 7 into 1. This is one of the way. And the rest is very easy. So rest is, if in place of 0 I put here some other value, say, so how many possibilities will be there? 4. That means 2 4 6 and 8. Okay, I can keep any of these. So there are 4 possibilities here. So now here what, how many possibilities are there? So now you have to focus. 0 is not allowed. Okay, and one number is already consumed here, 2 4 6 8. Out of these 2 4 6 8, one number is consumed here, one number is consumed here, and 0 is not allowed. So total two numbers are gone, or 2 digits are gone. So how many possibilities are left here? 8 possibilities are left here. Now here obviously here 0 can come. Okay, so obviously one number is gone here, one number is gone here, so again 8 possibility, and then 7 possibility, and here 4 possibility. So next is 8 into 8 into 7 into 4. And obviously these two will be added now, because when ending with 0, 4 digit number is created. Okay, so so we have to add these two. Okay, yes. So final answer will be 9 into 8 into 7 into 1 plus 8 into 8 into 7 into 4. This is my final answer. I hope everybody have got it. If anybody is having any doubt, please let me know. Otherwise, I will jump to the next slide. Okay. Yeah. Okay. So I'm jumping now. So next is 4-digit odd number without any repetition. Okay, odd number. So now I think it is similar kind of thing. Okay, but it will be slightly easier than the previous scenario. Why? Because here 5 possibility, 1 3 5 7 and 9. 5 possibility. Okay, so now one of the number is gone here, and 0 is not allowed here. So how many possibilities? 8 possibilities are here. Okay, now here how many possibility? One number gone here, one number gone here. So total 8 possibility again, and here 7. So answer is 8 into 8 into 7 into 5. That is the answer. Okay, yes. Please take snapshot. I will jump to the next slide now.
Done, sir.
Okay. Next is containing something. Okay, next constraint is containing. So this is a gate question. So what they are asking, 1000 to 4 times 9, if number is picked at random, probability that it does not contain 7. What will be the answer now? So obviously same box method. So directly indirectly what they are saying is 1000 to 449, that is nothing but your 4-digit number only. So they are talking about 4-digit number only. Okay, so what should be the scenario? So I will make 4 boxes. So at the first place, obviously 0 is not allowed. Why? Because number is starting with 1 now. So 1 to 9, I can have possibility 1 to 9. At first place 1 to 9 possibility. Okay, and pick that random, probability that it does not contain 7. Okay, so it does not contain 7, so here 7 is not allowed. So obviously how many possibilities are left? 8 possibilities are left here. Okay, so now here from 0 to 9 I can have, but 7 is not allowed, so 9 possibilities are here. Okay, here also 0 to 9, so again 9 possibility, because 7 is not allowed. Here 7 is not allowed, so again 9 possibilities from 0 to 9. Okay, so how many numbers? 8 into 9 into 9 into 9. And what they are saying, probability that if number picked at random that it does not contain 7. So how many total numbers are there? These are the desired. Okay, which does not contain 7. And how many total numbers are there? This is very simple. Okay, you can easily check it out. Rather simplest way is minus 1000. Okay, so how many are these numbers? So 8999, but you have to add 1 also. Why? Because 1000 is also included now, so it will be 9000. Are you getting it? See, if you are confused, you should say like this, from 1 to 3 how many numbers are there? So you will say 3 minus 1, that is 2. No, 2 are not there because 1 is also included. Na? So plus 1 you have to do. Like in array you do upper bound minus lower bound plus 1. So plus 1 we have to do. So that's why I have added plus 1. So it will be 9000. If this is okay with you, then it's really fine. But if still you have any doubt, rather it should be okay. But we can do by combinatorics also. Like this, from 1000 to 999. Na? So make a box simple. So from here, how many possibilities? 1 to 9. That means 9 possibility. Here 0 to 9. Here also 0 to 9 and so on. So here 10 possibility. Here 10 possibility. 10 possibility. So it is nothing but 9 into 10 into 10 into 10. That is nothing but 9000 only. So like this you can also get it. Okay. So the final, what is the probability? Probability is desired upon total. So 8 into 9 into 9 into 9 divided by 9000. This is my answer. Okay. We can calculate by calculator and all. I'm not going into calculations. Anyway, actually it is very simple also. So 1000. So 9 and 81, 81 into 8, 8 1 side, 8 is 64. So 0.648 is the answer. Okay. Yes, please take snapshot. I will jump to the next slide now. Okay.
Done, sir.
Okay. Next is, out of 26 alphabets, how many 5-letter words contain at least one A? This is really important. Out of 26 alphabets, how many 5-letter word contain at least one A? Okay, so at least one A means you can have 1A, 2A, 3A, 4A as well as 5A's also. So how you will count them? That will create problem for us. So I will go by complementary method. Are you getting it? Now at least 1A means what? 1A, 2A, 3A, 4A, 5A. Okay, so these are many cases. Okay, so total 5 cases you have to consider, and you have to apply rules and regulations. You will get the answer. It will be really difficult. So the better is do by go by complementary method. So I will say like this: 5-letter word na 1, 2, 3, 4. Yes. So how many possibilities are here? 26, 26, 26. 26, 26. By default, repetition is always allowed. I have told you letters and all these kinds of things. So total are 26 power 5. Okay, so now I will say no A means 0 A's. So at first place only 25 possibilities. Why? Because I will not consider A. Then again 25, 25, 25, 25. I think you have got it now. In the box I will apply like this. So this is nothing but 25 power 5. Okay, so now I will subtract it. 26 power 5 minus 25 power 5. So this will give us at least one A. I hope I have made the point clear to everybody. So please take snapshot. I will jump to the next slide.
Done, sir.
Okay. So next is exactly one A. So simple, same question actually. Out of 26 alphabets, how many 5-letter word contain exactly one A? So in place of at least, I have exactly one A now. So how we will do it? So total 5 places. Okay. So A can be either here, 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 or here. So 5 possibility for A. Okay. So and after that, what we will do? 25 power 4. I think you have got it, na? So if you have still any doubt, let me show you. So here one possibility, that means A. Okay, and rest everywhere 25, 25, 25, and so on. So 1 into 25 power 4. So now next time one will come here, next time one will come here, next time here, next time here. Okay, so if I write it more technically or more beautiful or elegant way, should be 5C1 into 25 power 4. Why 5C1? Because from the 5 places I will choose one of the place for A, and for rest of the places I will put other symbols. That is the meaning of 5C1 into 25 power 4. I hope everybody have got it. Please take snapshot. I will jump to the next slide now.
Done, sir.
Okay. Yes, so this is for exactly 1 and next is exactly 2A. Okay, exactly 2A. Same thing. So I think I should not waste time here. 5C2. From 5 places you will pick the 2 places. At that places A will be there, and for rest of the places 25 choices. So 25 power 3. I hope you have got it now. So you just fix 8 at 2 places, first 2 places, and then 25, 25, 25. Okay, next can be A can be here, A can be here, and 25, 25, 25, and so on. So directly what we are doing from here, from these 5 places, I am picking the 2 places. From 5, you want to pick 2 places, and then rest will have 25 choices. Okay, so that is the answer. Okay, and if you want to write more precisely, I can say like this also. 5C2. 5C2 means you have picked 2 places, and at these 2 places only one choice is there, na? So you can multiply by 1 also. Only one choice for A, and for rest 25 choices, and so on. Okay, so how you will expand 5C2? 5 into 4 divided by 2. I have told you many times. So into 25 power 3. This is my answer. Okay, please take snapshot. I will jump to the next slide.
Done, sir.
Done. Next is no A. No A means 0 A. So that is very simple. So no A should be there. So 25 power 5. Very simple. Okay. Yes, next is at most 1A. At most 1A means 0A or 1A, or means plus. So 0A means 25 power 5. 1A, I have already told you, 5C1 into 25 power 4. Okay. Yes, that's it. So I think you can do at most 2A, at most 3A, and so on. We can do all these things. Okay, I'm not going into details. It will simply waste our time. Okay, I'm jumping to the next slide now. So next is together. So next type of constraint is together. Okay, so for example, we have this word equation, and I will say all vowels together. Okay, or all vowels not together, and so on. This type of question have been asked in GATE many times. Okay, so let me concentrate on all vowels together. So how we will do it? So what are the vowels in this equation word? A, E, I, O, U. All vowels are there. So this is very beautiful word. So this the beauty of this word is all the vowels are in the single word equation. Okay, all the vowels are there. Okay, anyhow, so all vowels together I'm saying now. So whenever we use the word together, so you will simply apply glue over it. You will consider this as a box now. Okay, apply glue between all of these, so they will not get separated. So you will consider it as a box, and rest what is remaining? Q, T, and N. Yes, Q, T, and N are remaining. That's it. So now here we have applied glue. So how many? Now you will say how many letters are there? 1, 2, 3, and 4. 4 letters. So how many ways to arrange them? Obviously 4 factorial ways. Now after 4 factorial ways, our work is not yet over, because here also we can do arrangement. Now, so how many arrangements are there? So obviously 5 words are there, 5 letters are there. So how many ways you can arrange them? 5 factorial ways. So this is my answer. Okay, so together you will solve like this. So 4, why 4 factorial has come? Why 4 factorial has come? Because of this thing, 1, 2, 3, and 4. You will arrange them. Why 5 factorial has come? Because of this thing. You can go inside and you can arrange them also. That's why. Please take snapshot. I will jump to the next slide.
Done, sir.
Okay. Next is all constraints together. Okay, oh, sorry, all consonants together. Yes, all consonants together. So how we will do it? So that is also very simple. Q, T, and N were the consonants. No? So all these should be together, and A, E, I, O, U, they can be anywhere. So what will be our answer? So I will consider this as 1, 2, 3, 4, 5, 6. So 6 factorial multiplied by inside how many? 3 factorial. So why 6 factorial? 6 factorial is because of this. And why 3 factorial? 3 factorial is because of this. Next is all vowels together, all consonants together. So all vowels together, sorry, all vowels together first. So A, E, I, O, U, and Q, T, N. You will apply glue here, apply glue here. So now you will consider this as one character, this is one character, or one letter, you can consider anyway. So how many ways to arrange them? 2 factorial. Why 2 factorial? Because these are the 2 ways. Okay, 2 ways na. This can be before and this can be before also. We can swap them also. So 2 ways. So our work is over? No, our work is not yet over. So we have to arrange 5 factorial ways, and here we have to arrange 3 factorial ways. So this is my answer. Okay, please take snapshot.
Done, sir.
Okay. Next is all vowels not together. As soon as you find not kind of thing, you will think like it is a complementary problem. Okay, it is a kind of complementary problem. So how we will solve it? So see, equation word to equation word, how many character? 1 2 3 4 5 6 7 8. There is no repetition at all. So total number of jumble words 8 factorial. Okay, and all vowels not together na. So what are the cases where all vowels were together? All vowels together case was hmm, all vowel together was 4 factorial into 5 factorial. So I will simply subtract it. 4 factorial into 5 factorial. This is my answer. So from the total what we have subtracted all vowels together. This is the way to do it. Otherwise you will get confused in gate exam. There will be a hell lot of cases which you have to consider all vowels not together. Okay, yes. So please take snapshot. I will jump to the next slide.
Done, sir.
Okay, next is, so now they can ask question like 5 boys and 6 girls are there. So four questions I think you can answer. All boys together, next all girls together, all boys together, and all girls together. I think you can answer these 3 questions very easily. Okay, and I am leaving them as homework for you. I have just solved many questions like this. Next is at least 2 boys separated. So same I have explained you just now. Okay, all vowels not together kind of thing. So let me do it, no problem. At least 2 boys separated. Okay, so how we will do it? At least 2 boys separated means what? So again complementary problem. Okay, so how we will solve it? So 5 boys and 6 girls, so 11, total 11 factorial ways. So minus, so to all boys together. So how you will say all boys together? Okay, so if you consider all boys together, then you will apply glue over it. Okay, so 6 girls plus 1 thing, so 7 factorial ways multiplied by, so 5 boys they can be you can say arranged now, so 5 factorial. So this is my answer. Okay, at least 2 boys separated is this answer. So at least 2 boys separated means I will consider all boys together, and from the total I will subtract it. I think you have got it. If anybody is having any doubt, please you can ask me. Otherwise, I will jump to the next slide.
No, sir, no doubt.
Okay. So I'm jumping to the next slide now. Next is Mississippi, same, all S together. So I think it's really simple, all S together. So you will apply glue over it, S, 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 S. And then I will say M, I, 4 times I is there, yes, and 2 times P are there. So why I'm doing it? Because some of you might get confused here. So 1 2 3 4 5 6 7 8 9. So 9 factorial divided by 4 factorial 2 factorial. Let me see it again. So, 4s 1, then 2 3 4. Okay, I think I have written I 5 times. Sorry for that. So it should be 8 factorial. Okay, yes, 8 factorial. So now it's okay now. 1 2 3 4 5 6 7 8. Yes, 8 factorial divided by 4 factorial 2 factorial. This is my answer. Okay, and now I will arrange them. So how many ways to arrange them? Only one way, because all are identical. So this is my answer. Okay, so please do not get confused in such type of questions. Okay, so please do not by heart anything. So like we will consider them as a single box, and then we will try to arrange them, but there is only one way to arrange them. That's why I have applied here 1. And why 8 factorial? Because of these 8 things. Okay, and why 4 factorial? Because of i's were repeated 4 times, and why 2 factorial? P was repeated 2 times. Now please do not say S has repeated 4 times, so divide by 4 factorial again, and so no, I will not do it, because I have I have applied glue over it. Consider this as a black box. Okay, so this as a black box, you cannot see what is inside it and all. So do not say divide by 4 factorial and all. Okay, please take snapshot. I will jump to the next slide.
Done, sir.
Okay. Next is, so we have 5 A's, 3 B's, and 2 C's. How many jumble words in which all B's are together? Okay, how many jumble words in which all b's are together? So very simple, 5 plus 3 plus 2, that is 10 factorial divided by 5 factorial, 3 factorial, 2 factorial. This is the answer when I will say that all possible jumble words, all possible jumble words. Okay, and now what they are saying, jumble words all be together, so simply apply glue over it. So when I will apply glue over it, I will consider these three b's as a black box. So what will be our answer? 5 to 7 plus 1. Okay, so 5, yes, so 8 factorial. Okay, 8 factorial divided by the a's are repeated 5 times, so 5 factorial, and c's are repeated 2 times, so 2 factorial. This is the answer. This is the answer for this. And this, by chance, I have made a new question, all possible jumble ones. Okay, so 8 factorial, 5 factorial, 2 factorial. This is my answer. Okay, and multiply it by 1. You can do like this. So why 1? Because all b's are similar. Okay, all b's are similar, so that's why I have multiplied by 1. Please take snapshot. I will jump to the next slide now.
Done, sir.
Okay, next is all letters of same type together. Okay, all letters of same type together. So I will consider everything as together. So glue over it, apply glue over it, 1 1 1. So 3 factorial ways. That's it. This is my final answer. Okay, and if you want to arrange them also, then I will write like this: 3 factorial into 1 factorial into 1 factorial into 1 factorial. This is my answer. Answer will not be changed, but I have written it so that everybody get crystal clarity. Okay, so I have applied glue over everything. So how many letters are there? 3. So 3 factorial ways to arrange them. And how many ways to arrange a's? Because all are identical, so 1 1 1 and so on. Okay. Please take snapshot. I will jump to the next slide.
Done, sir.
Okay, next is equation. So I have written e 2 times. Okay, yes, and all vowels are together. So this kind of question have been asked in gate many times, because many students will be in hurry and they will forgot to notice that e has been repeated 2 times in the word equation. Okay, equation is a very special word. Now I have told you all the 5 vowels are there. Okay, but they will apply e 2 times just to confuse you, and they want to ask all vowels together. Now how you will answer it? All vowels together. So a, e, I, o, u, and e is repeated 2 times, so you will apply this also. So now you will apply glue over it. Okay, and q, t, n was there. Okay, so this is 1 1 1 1 and 1. So 4 factorial ways divided by, sorry, 4 factorial is over multiplied by. So you have to arrange them. So how many are there? 1 2 3 4 5 6. 6 factorial divided by 2 factorial, because e is repeated 2 times. Same. Okay, so this is my answer. Okay, so why 6 factorial by 2? Why 6 factorial by 2? Because of this thing. I consider this. And why 4 factorial? 4 factorial because of this. Now take snapshot. I will jump to the next slide.
Done, sir.
Okay. Next is no two objects together. Okay, so I think you have got it. Now this is will just like a complementary problem. Okay, so equation word is there, and no two consonants should be together. So how no two consonants should be together? So actually see, better way, much better way is you first try to arrange. See, actually it is not a complementary problem. I should say like this. It is not, you should not consider that two object together and I am saying no two object together. Actually this is not complementary problem. Let me write it properly. It is not a complementary problem. We have to solve it directly. How we will solve it? Let me show you. So equation is the word, and no two consonants should be together. So vowels, there is you can say no consonant on the vowels. So vowels are a, e, I, o, u. Okay, so now I will say, so these are the places 1 2 3 4 5 6. 6 places are there, and how many consonants are there? Q, T, and N. So 3 consonants are there. So first from these 6 places, I will pick the 3 places, and on these 3 places I will arrange them. So 6C3, 6 3 ways, such that no 2 consonants will be together. So now our work is not yet over, because I can arrange them also in 5 factorial ways. So 6C3 into 5 factorial is my answer. Okay, like this you have to do it in this kind of question. This is a standard way of doing. Okay, yes. So 6C3 into 6C3. Why we have done 6C3? Okay, 6C3 is done because I want to uh, choose the you can say place. Okay, places. Choose the places. Okay, choose places. And 5 factorial to arrange the vowels. Okay, sorry, we have to arrange these also. Now that's why see, I'm writing these things so that we get more clarity. So qtn is there, so we can arrange them also. Now so you have to multiply it by 3 factorial also. So why I'm multiplying it by 3 factorial? Because you have to arrange these also. So from the 6 places you have picked the 3 places. So say for example you have placed q here. Let me write it with another color. Q here, T here, and N here. Okay, so now you can arrange them also, no? Qtn, Tqn, Ntq, and so on. So 3 factorial ways will be arranged, will be more, because we have to arrange them also. So finally, what can be the answer? 5 factorial multiplied by 6p3 also. I have told you many times now. 6c3 multiplied by 3 factorial, that is nothing but 6p3. Okay. Yes. Now please take snapshot. I will jump to the next slide.
Done, sir.
Okay. Yeah, next is no two vowels together. So same type of question. So no two vowels together, same way. So how many are consonants? QTN. So are you getting it now? So when I have said no two consonants together, so first I have arranged the vowels, and then on the places which they have created, on those places I have put the consonants. So like this, no two vowels together means first I will arrange consonants Q, T, and N. So they will create how many places? 4 places. And how many vowels are there? 5 vowels are there. So on the 4 places, how these 5 vowels will sit? Not possible. So we should not say not possible, we should say answer is 0. I have told you many times, in counting problem we should not say not possible and kind of thing. So we will say 0 is the answer, because counting problem, so we want number as the answer. So number will be 0. Okay, yes. Why? Because if you want me to write the answer, then I will write like this. So I will say 3 factorial ways to arrange this QTN, and then from the 4 places I have to pick 5 places, and then I will arrange them. So obviously 4C5, that is 0. So answer will be ultimately 0. Okay. Now please take snapshot.
Done, sir.
Okay. Next is Mississippi, no two S together. Okay, Mississippi and no two S together. So how we will? We will consider the other things. Okay. So MIIIIPP. Okay. So yes, 1 2 3 4 5 6 7 8. So 8 places. From the 8 places, I will choose 4 places. Why? Because there are 4 S. From the 8 places, this is important question, please try to focus here. 8C4. Now 8C4, now I should arrange as? No, because they are all identical. So only 1 factorial. Okay, so now my focus will be now my focus will no longer remain on S. So now my focus will be here. So I have to arrange them also. So how many are there? 1 2 3 4 5 6 7. So multiplied by 7 factorial. Okay, 7 factorial now divided by, because I are repeated 4 times and P are repeated 2 times. So this is my final answer. 8C4 into 1 factorial into 7 factorial divided by 4 factorial, 2 factorial. Okay, please take snapshot. I will jump to the next slide now. So that's why, see this, I can immediately see in the previous slide also I can yeah, here I can immediately say 6c3 to 3 factorial. No doubt I have said you 6p3. Okay, after writing 5 factorial I can immediately say from the 6 places I want to pick 3 places where I will arrange q, t and n. So 6p3 is the answer. I can directly write like this also, but I have not written it like this. I have written it like this first and then I have converted into this. Why? Because I have told you many times, forget about permutation. You should say first combination, that means choose and then arrange, choose and then arrange. See, the difference lies here. So first we have chosen and then arranged. So arrangement was not allowed here because all were equal. If you try to by heart something, you will write 8p4, but 8p4 is not the answer. 8c4 is the answer. Okay, in GATE exam you will find option 8p4 also. Many of the students will take 8p4 because from the 8 places you want to pick 4 places from where these s will be arranged. But if you think carefully, there is no need to arrange all these s's because all these s are identical. That's why I'm not teaching you to write 8p4 and so on. Okay, I am writing like 8c4 into 1 factorial and all. Okay, yes, I'm jumping to the next slide now. Next is a GATE question. So how many binary numbers with m zeros and n ones such that no two ones together? So same type of thing. No two ones together means no two ones together. So I will arrange the zeros. So now I think you have got it. I will arrange the zeros. So m zeros are there. So obviously m zeros will create how many places? Like see this 1, 2, 3, 4, 5, 6. 6 zeros I have taken. 1, 2, 3, 4, 5, 6. So they have created 7 places now. So m zeros will create how many places? M plus 1 places. Now from these m plus 1 places I will choose how many ones I want to arrange? N. So I will say m plus 1c n. Okay, so now after choosing those places and I have put the 1, so now we will arrange those ones, but I do not need to arrange those ones. Why? Because all these ones are identical. Okay, and then my focus will be to arrange the zeros, but all these zeros are identical, so I do not need to arrange them also. So I will write like this. This is very important question, and that's why this type of question have been asked in GATE repetitively, because I am not giving you any kind of formula or cookbook to you. Because if I give you a cookbook, then you will immediately answer the questions and I will give you a formula, you will by heart it and so on, but I'm not going there. Going into all these things. Unfortunately, many coaching institutes do like this. That's why GATE is asking such kind of questions so that everybody get confused. Okay, so I am teaching you from the scratch how we are doing it. From I am telling you the approach. Okay, I'm not giving you the formulas and all. Okay, yes, so I think everybody have got it. M zeros are there, so first I will arrange these m zeros. Okay, and then it will create m plus 1 places. So m plus 1, I will choose the n places for ones, and then I will arrange ones. Obviously all ones are equal, and then I will arrange the zeros. Obviously all zeros are equal. That is my answer. Please take snapshot. I will jump to the next slide. Okay, I'm jumping now.
Done, sir.
Okay, next is alternating sequence. Okay, this is also very important. So for questions will be like 4 boy 5 girl, no 2 boys together and no 2 girls together. This type of question have been asked. This is known as alternating arrangements. Okay, so just for the sake of practice, 4 boys and 5 girls na. So first I will answer no 2 boys together, then I will answer no 2 girls together, and then I will answer no 2 boys together and no 2 girls together. Okay, so first let me answer no 2 boys together. No 2 boys together. How you will solve it? No 2 boys together. Again, very simple. So 5 girls are there, so they will create 6 places. So 6 c4, 6 c4 ways. Why? Why I have chosen 4? Because 4 boys are there. So after that I will arrange the boys and then I will arrange the girls. So I think this is the answer. Okay, everybody have got it. Now I'm not making the figure and all, because everything is fit in your mind. So next question is no 2 girls together. No 2 girls together. So if we say no 2 girls together, then first I will arrange the boys. After placing the boys, I will be getting what? 4 plus 1, that is 5 places will be there. From 5 places I will choose 5 places, obviously only one way, and then I will arrange the girls and then I will arrange the boys. This is the answer. 5c5 is 1 only. Okay, because from the 5 you have to choose the 5. Obviously one choice is there, only one way is there, so that is that's why answer is 1. So 1 into 5 factorial into 4 factorial. Okay, this is the way. So now I will answer this question. And no two boys together and no two girls together. 4 boys and 5 girls. Please take snapshot. I will jump to the next slide.
Done, sir.
Okay. So next is this thing. Na? So 4 boys and 5 girls, no two boys together and no two girls together. This is known as alternating arrangement. So let me tell you the alternating arrangement. Very simple. So no two boys and no two girls together. So I can start with girl, then boy, then girl, then boy, then girl, then boy, then girl, then boy. So 5 girls now, 1 2 3 4 and then 5 girls, and here we have arranged 4 boys. Okay, this is one of the way. So if I start with a boy, then boy girl, boy girl, boy girl, boy girl. So 4 boys 4 girls are over. So 5 girls. So fifth girl, where I will put the fifth girl? I cannot put here. Why? Because obviously 2 girls will be together. I have said no 2 boys and no 2 girls together. So only way is I should put the girl here. Now the moment I put the girl here, so obviously both ways are only same. Okay. So only one way to arrange them. So now after arrangement, obviously now I will arrange the girls and boys. So after girls, how many ways? 5 factorial. Boys, how many ways? 4 factorial. So 1 multiplied by this. 1 is the arrangement of boys and girls. Okay, and then 5 factorial to arrange the girls, 4 factorial to arrange the boys. Okay, yes, please take snapshot. I will jump to the next slide.
Done, sir.
Okay, next is 5 boys and 5 girls. Now tell me alternating arrangements. Okay, first question was 4 boys and 5 girls. These were the only one arrangement was possible. Now tell me how many ways to arrange them. 5 boys and 5 girls. So let me show you. Boy girl, boy girl, boy girl, boy girl. 4 boys, yeah, boy girl. Okay, so 5 boy 5 girl over. Next is girl boy, girl boy, girl boy, girl boy, girl boy. So 5 girls and 5 boys over. So only 2 ways are there. So now 2 will be multiplied by, so boys arrangement 5 factorial, girls arrangement 5 factorial. So 2 into 5 factorial into 5 factorial, this is my answer. I think you have got it. If you still anybody is having any doubt, let me write it properly. For this answer will be what? 5 factorial multiplied by 5 factorial. For this answer will be what? 5 factorial multiplied by 5 factorial. Okay, so this or this, na? So obviously I will apply plus. So this is nothing but 2 into 5 factorial into 5 factorial. Yes, so I think it's really very easy. If anybody is having any doubt, you can ask me. Otherwise, I will jump to the next slide.
No, sir, not a problem.
Okay, so I'm jumping now. Next is 5 boys and 4 girls. So again, same kind of thing. 5 boys and 4 girls. So I will start like this: boy, girl, boy, girl, boy, girl, boy, girl. 4 boys, 4 girls over. Fifth boy. Where fifth boy will sit? Fifth boy will sit like this. If you start like this: girl, boy, girl, boy, girl, boy, girl, boy. 4 boy, 4 girls are over. And now where fifth boy will sit? Obviously, fifth boy will sit here itself. So same. I'm getting same. Okay, so only one way. So 1 multiplied by 5 factorial multiplied by 4 factorial. 5 factorial because of boys, 4 factorial because of girls, and only one way to arrange them. So in the next slide, I will show you the summary. Please take snapshot. I will jump to the next slide.
Done, sir.
Okay, so next is, see, this is the really very simple summary. So if we have n boys and n plus 1 girls, then how many ways to arrange them? So obviously only one way will be there: girl, boy, girl, boy, girl, boy, and last will be girl only. Okay, because n plus 1 girls are there, na? So it will start with girl and end with girl, and in between we have boy, girl, and so on. If we have n plus 1 boy and n girls, so n plus 1 boy means 1 extra boy, so obviously it will start with boy and end with boy, and in between we have girl, boy, and so on. Okay, and if we have n boys and n girls, then obviously 2 ways: boy, girl type, or girl, boy, girl, boy type. Okay, so how many ways will be there? N factorial ways to arrange the boys, n plus 1 factorial ways to arrange the girls. Same, n factorial, n plus 1 factorial, and here n factorial into 2 factorial. Why? Because n boys and n girls. So n into n factorial into n factorial into 2. Why into 2? Because we have 2 ways. So now if I say n boys and n plus 2 girls, obviously 0 ways. Why? Because n boys will create n plus 1 places. Now at n plus 1 places, how n plus 2 girls will sit? Not at all possible. So that's why answer is 0. Same, n plus 2 boys and n girls will create n plus 1 places. At n plus 1 places, how n plus 2 boys will sit? Not possible. So at here at least 2 boys will be together. For sure at least 2 boys will be together. Okay, so here also it will create problem. So 0 0 everywhere 0. So only 3 possibility for alternating arrangements, that is either n boy, n plus 1 girl, or n plus 1 boy, n girl, or n boys and n girls. Only 3 possibility for alternating arrangements. Rest other possibilities are not allowed for alternating arrangements. Okay, because they will produce 0 result. This is the summary. Please take snapshot. I will jump to the next slide. I'm jumping now.
Done, sir.
Okay, next is binary numbers, 5 zeros and 5 ones. This is a gate question, by the way. We have a binary number 5 zeros and 5 ones, so that 0 and 1s are alternating. Okay, so most of you will take this option. A option will be this in gate exam. So I have actually I will never tell formulas and all, but here I have tell formula, and we will not apply it. Please we will not apply it, because if you apply the formula 5 zeros and 5 ones, so 5 factorial into 2, this is my answer. But no, this is not the answer. Why? Because 5 zeros all are identical, 5 ones all are identical. So how you will arrange them? So no way to arrange. So obviously, so 5 zeros and 5 ones. So like this, 1 0 1 0 1 0 1 0 1 2 3, yeah, 1 0. This is one of the way. Second is 0 1 0 1 0 1 0 1 0 1. That's it. No other way. So only 2 is the answer. Okay, only 2 ways. No other way, because there were boys and girls. Obviously all the boys and girls were different. That's why we arrange them and all. How you will arrange the zeros? Okay, zeros are identical only. Similarly, ones are identical only. So only 2 ways are there. Please try to focus. This is a gate question. Okay, so they will ask questions on a very different pattern. If anybody try to by heart something, he will definitely get confused. Okay, I'm jumping to the next slide now. Next is, yeah, 5 zeros and 6 ones. How many ways? I think you have got it. Only one way. 6 zeros and 5 ones, only one way. 5 zeros and 7 ones, 0 ways. Why 5 0 and 6 1 only one way? So start with 1 0 1 0 1 0 1. So if I start with 1, okay, let me say like this: 1 2 3 4 5. So 3 zeros, 4 zeros, 4 ones are over. 1 0 1 0 1 0. Okay, and then 1 0. So 5 zeros or 5 ones are over. Where we will apply 6 1. 6th one will be applied here only. Now if I start with 0 1 0 1 0 1 0 1 0 1, so 5 zeros and 5 ones are over. Where we will apply 6th one? I will apply here only. So obviously both are same. Both are same. So obviously I have written here only one way. Similarly here also only one way. 5 zeros and 7 1. I think you have got it. 5 zeros are there. So obviously it will create 6 places. Now on 6 places, how you will apply 7 ones? Not possible. So answer is 0. Okay. Now please take snapshot. I will jump to the next slide. Okay.
Done, sir.
Next, we are going to start circular permutation. Circular permutation, we have 2 cases, distinct and identical. Let me tell you these things. 5 boys on circular table, how many ways? So we have 5 boys and we want to put them on a circular table. Then how many ways? So formula is, see, if they were, we want to arrange them in a linear fashion, then answer will be 5 factorial. But if I want to arrange them in circular fashion, answer will be 5 factorial divided by 5. So 4 factorial is the answer. So generalized way is n minus 1 factorial. So if we have n objects and we want to arrange them, we want to arrange them in a circular table. Okay, so answer will be n minus 1 factorial. What is the proof? Don't worry, in the next slide I will tell you the proof also, but please note down this formula. Linear only 5 factorial, but in circular 5 factorial divided by 5, answer is 4 factorial. So so generalized will be n object circular, n minus 1 factorial are the ways. Okay, let me write it properly, 4 factorial. Okay, yes, now take snapshot. So what is the proof that why we are dividing by 5 and all? Let me tell you in the next slide. Please take snapshot. Okay.
Done, sir.
So now for simplicity, I will take 3 boys because 5 will create problem for us. Linear arrangement B1, B2, B3, B1, B3, B2. One is at the first place, then 2 arrangements, then B2 will be there, then B1, B3, and B2 will be there, B3, B1, and then B3 will be there, B1, B2, and then B3 will be there, B2, B1. So now let me put every these 6 in circular fashion. So first way, how you will arrange them? So I will make 6 circles. 1, 2, 3. Okay, yeah, and here let me write 4, 5, 6. So first B1, B2, B3, B1, B2, B3. Simple. Next B1, B3, B2, B1, B3, B2. Next B2, B1, B3. Next B2, B3, B1. Next B3, B1, B2. Next B3, B2, B1. Now please check B1, B2, B3. This is one of the way. Please see this. Say like this B1, B2, B3. So now if you say like this B1, B3, B2, obviously they are different. These two are not identical. These two are not identical. What about this scenario? B2, B1, B3. So B1, B3, B2. See like this. Please try to see like this. B1, B3, B2. So it is just like this only. Are you getting it? B1, B2, B3. So you just rotate it. Okay, you will get it. These two are identical. If you see like this B1, B3, B2. See this B1, B3, B2. Same B1, B3, B2. Okay, same. So you see clockwise. Clockwise you see B1, B3, B2. Same B1, B3, B2. Okay. Yes. Next B2, B3, B1. So same clockwise you see B1, B2, B3. So it is just like this. Okay. So let me label it. This is say 1. 1. So this is also 1. Okay. Yes. And this is 2. And this is also 2. Now see this like this B1, B2, B3. Again it is just like 1. See this B1, B3, B2. It is just like 2. So only 2 arrangements are there for 3 boys. So linear arrangements were total 6. Why? Because of 3 factorial. Okay, but circular arrangements are 2. Why? Because 3 factorial divided by 3. 3 factorial divided by 3, and it comes out to be 2 factorial. Why divided by 3? Because 3 arrangements are you can say mingled up to 1 only. Okay, so this is arrangement number 1. Okay, and this is also arrangement number 1. This is also arrangement number 1. So these 3 are counted only once. Similarly, this is arrangement number 2, this is arrangement number 2, this is also arrangement number 2. So these 3 are counted only once. So that's why divided by 3. All 3 are merged to 1 only. 3 groups merged to 1. So divided by 3. So 3 factorial divided by 3, 2 factorial. So I hope I have made I have given you the proof properly. So this is the way. Okay, so generalize. Now I think I can simply generalize. So linear arrangements, if we have n objects, linear arrangements n factorial, but circular n factorial divided by n, that is nothing but n minus 1 factorial. Please take snapshot. I will jump to the next slide now. Okay, I am jumping now. So now I will consider another case, that is garland case. Okay, garland or necklace case. Okay, but not the same thing. Garland, I think you know na, what we say in Hindi, फूलों वाली माला जो होती है वही garland. Okay, next is necklace. Garland or necklace, one and the same thing. Okay, so let me say you like if we have say red, green and blue flower. Okay, we have 3 flowers of different colors, and if we want to arrange them linearly, obviously we will be having 3 factorial ways. So red, green, blue, red, blue, green. Sorry, let me write it properly. Red, green, blue, then red, blue, green, then green, red, blue, green, blue, red, and the last will be blue, green, red, blue, red, green. Okay, I think you have got it, na? So first I will fix R and then GB BG, then I will fix G, then RB BR. Next I will fix B, then GR RG. 6 ways are there. So now if I arrange them on a circular fashion, what I will get? See, 6 circles I will draw. Red, blue, sorry, red, green, blue, na? Red, green, blue. Again, this is mapped to this. Red, blue, green. Red, blue, green. This is mapped to this. Okay, now you will say obviously they are not equal, but actually they are equal. In circular arrangement, when boys were sitting like this, they were not equal, I have told you, but here they will be equal. Why they will be equal? Because you can flip the garland, na? Okay, you just flip it 180 degree, like from here, if you are seeing from the top, you are seeing like this, but if you see it from the bottom, what you will get, you will see like this. Are you getting it? So you just flip it 180 degree, you will get this thing. Okay, flip 180 degree, you will get it. So both are same. So now I think you have got it. I should not waste time here and make 6 diagrams and show you. I think you have got it. Everything is same only. So what should be the formula for garland or necklace kind of problem? So 3 factorial divided by 3, just because for circular permutation. And next I will divide by 2 also. Why I will divide it by 2? Because clockwise and anti-clockwise they are same. Flip 180 degree, you will get the answer. So obviously only one is there. So what is the generalized formula? Generalized formula, I think you have got it. Generalized n minus 1 factorial divided by 2. Okay, so let me write it properly. See, why we have not done this in the case of your boys problem? Because you cannot put boys on a circular table and you flip it 180 degree. All the boys will fall down if you do like this. Okay, so everybody will should sit properly, na? So from the top only you can see the table. From the bottom you cannot see. If you want to see from the bottom, then you have to flip the table, and as soon as you flip the table, each and every boy will fall down. Okay, so that's why we cannot do like this in boys problem or in circular table problem. Okay, so let me generalize the things. So for linear arrangement, if we have n objects, n factorial ways. Okay, for table problem, circular table problem, n minus 1 factorial. Why? With proof we already know. For garland problem or necklace problem, we will say n minus 1 factorial divided by 2. Why divided by 2? Because 180 degree flip. Okay, why divided by 2? 180 degree flipping is allowed, but here no flipping. Okay, you cannot flip the table, otherwise boys will fall down. Okay, yes, so please take snapshot. I will jump to the next slide. Done?
Done, sir.
Okay. Yes, so next is 5 boys and 6 girls sit on a circular tables and all boys should be together. This is important question. So now we will try to apply constraints on circular arrangements. Okay, so 5 boys and 6 girls are there and they want to sit on a circular table, and what we are saying, all boys should be together. So if it was linear arrangement, please tell me something. If it was linear arrangement, in case of linear, I will apply glue on the boys. So 6 objects are there and 6 plus 1, that is 7. So 7 factorial ways to arrange them, and then boys will be you can say arranged. So 5 factorial. So for linear, 7 factorial into 5 factorial. I think everybody is comfortable with it. What about my circular arrangement? So now we have to think about it. All boys should be together and 6 girls are there. Okay, so what I will say, total you can think there are only 7 objects. You can think like this. Okay, so 6 plus 1, 7 objects are there, and I have told you 7 minus 1 factorial ways to arrange them. Now after arranging, we have to arrange the boys. Now here confusion will start, whether we have to do 5 factorial or 4 factorial. 4 means because they are in circle, you have to do a circular arrangement and all, but no, I will apply only 5 factorial. Why 5 factorial? Because see this, if on a, in a circle, see, these are the places where boys will be kept. Here boys will be kept and here we have girls. Okay, all boys should be together now, like this. So if we consider an arc of a circle, consider a circle of infinite radius, so obviously it will be a straight line only. Okay, so you can simply see like this now. This is, no doubt this is a circular, but it is not circular now, it is half circle kind of thing. It is just like an arc. So on arc I am putting the boys. So see, if I say that put the boys here on a straight line, or if I say put boys here on an arc, so there is no difference between them. I can put boys here also and here also, no difference. But once I made a circle, then obviously difference will come and all. So please do not get confused here. So for circular arrangements, 7 minus 1 factorial will be 100%, it will be there. Why? Because 6 girls and because of 5 boys, I will apply glue over it. So total 7 objects are there. So circular arrangement 7 minus 1 factorial, that is for sure. And after it, I will apply 5 factorial for the boys. Okay. So I hope I have made the point clear. Please take snapshot. I will jump to the next slide now.
Done, sir.
Next is no 2 boys should be together. So same, 5 boys and 6 girls, and no 2 boys should be together. So same kind of thing. If it was a linear arrangement, no 2 boys should be together. So first I will arrange the girls. After arranging 6 girls, I will get 7 places. So from the 7 places, I will pick the 5 places for the boys. Okay, and then I will arrange the boys, and then I will arrange the girls. Okay, I think you have got it now. Seven places will be created by the 6 girls. Okay, I think you already know I have done it now. 6 girls are there, so 7 places will be generated. Yes, any doubt here?
No, sir.
So okay, so 6 girls, so 7 places will be there. So from the 7 places, I will pick the 5 places for the boys, and then I will arrange the boys, and then I will arrange the girls. No problem. So now if we have a circular arrangements, now see this. So 1, 2, 3, 4, 5, 6. So 6 girls. G1, G2, G3, G4, G5, G6. 6 girls are there. So now how many places they have created? 1, 2, 3, 4, 5 and 6. That is the difference. So here only 6 places have been created, but in linear 7 places were there. So now from these 6 places I have to choose 5 places from at which I will put the boys. Okay, and then I will arrange the girls and boys. Okay, so now can anybody tell me how I should do it? Okay, so now please tell me how we should do it. So since 6 girls are there, so see, now you have to think. Okay, so the basic thing is, so you will apply circular arrangement on the girls now, because first you have arranged the girls. So 6 girls are there, so obviously 6 minus 1 factorial ways to arrange the girls. So now girls have been arranged in a circular fashion, and now I will put the boys. So how many ways to put the boys? So now obviously see how many places are there for the boys? So for 5 places we have taken. So obviously 5 factorial multiplied by 5 factorial. Okay, so answer will be 65 into 5 factorial into 5 factorial. So why 6 minus 1? Because girls I have arranged it in a circular fashion, or circular girls. Let me write it as a hint, circular girls. Okay, and then we will arrange the boys. Okay, once girls arrangement is over, then I have picked the 5 places. Now simply you should say like this: we have created 6 places. Now from the 6 places I have picked the 5 places. Now at these 5 places I will put the boys, so no problem at all. Okay, so 5 places 5 boys, so obviously 5 factorial ways, that's it. But girls, we have arranged them in a circular fashion. Okay, first girls have been arranged, and then see I think you have got it now. Ways, what was the way? First girls have been arranged. Okay, and then we have created girls have created 6 places, and on these 6 from these 6 places, out of these 6 places, at 5 places boys will sit. So that's why we have got this answer. Yes, please take snapshot. I will jump to the next slide.
Done, sir.
Next is no two girls together. No two girls together. So how I will show it. So first I have to arrange the boys circular fashion. So 5 boys and 6 girls. So 5 boys. 1, 2, 3, 4, 5. So obviously how many places they will create? 1, 2, 3, 4, 5. 5 places they will create. So how 6 girls will sit on it? Not possible. So answer is 0. Okay. So the difference between linear and circular is in linear plus 1 places are generated, but in circular only n places will be generated. Okay. So linear n plus 1 places, but circular only n places. Only n places created. N plus 1 places created. Okay. By obviously by placing n things and all. Okay. So linear n plus 1 places created, but in circular n places are created. Okay. Please take snapshot. I will jump to the next slide.
Done, sir.
Okay. So next is no two. See this, no two girls G1 and G2 always together. Okay. Question is two girls G1 and G2 should always be together. How we will do it? So first is 5 boys and 6 girls I am taking. Second is 5 boys and 5 girls I am taking. Okay. So let me tell you this thing how we will do it. So two girls G1 and G2 should be always together. Now, so I have told you many times, together means apply glue over it. G1 and G2. Consider it as a black box. This is you will consider this as only one girl only now. Okay. So you will consider it as a one girl now. Okay. So if we have 5 boys and 6 girls, so now obviously how many girls are remaining? 5 girls are remaining now. Okay. So 5 girls are remaining and 5 boys are there. So this will become 5 boys and 5 girl case. Okay. And in circular arrangement I have to arrange them. So obviously 9 factorial is the answer. Okay. After, but 9 see why 9 factorial? Because 5 boys and 5 girls, so 5 plus 5, that is 10 objects. 10 objects we want to arrange circular fashion, 9 factorial. But because I have applied glue over G1 and G2, so I have to multiply it by 2 factorial also. Why? Because I will arrange G1 and G2 also. Okay. So 9 factorial into 2 factorial is my answer. Okay. I hope I have made the point clear to everybody. And what about my this question? 5 boys and 5 girls. 5 boys and 5 girls. So same thing. So I will say I am having 5 boys and 4 girls. So how many objects are there? 5 plus 4, that is 9 objects are there. 9 objects. So obviously how many ways to arrange them? 8 factorial ways to arrange them. And then these two girls should be together. So 2 factorial will be multiplied. Okay. So and what if I want answer in linear fashion? This was obviously circular na. If we want linear fashion, then I think you have got it. So 10 if let me do it with green color, linear. So 10, clearly I will write 10 factorial ways. Obviously when 10 objects are there, then I can arrange them in 10 factorial ways. So into 2 factorial, this is the answer for the linear. Okay. And for this, since we have got the 9 objects, so obviously 9 factorial ways to arrange them and into 2 factorial. That is the linear arrangement. Okay. And these are the circular arrangements. Circular. Please take snapshot. I will jump to the next slide now.
Done, sir.
Okay. Next is 5 identical green beads, 6 identical blue beads, 3 identical yellow beads. How many necklaces are possible? So I think I have mingled up 2 problems now. Mississippi problem, that is permutation with the limited repetition, and this circular arrangement. Okay. So now let me say it. So assume we want straight method, straight. And I do not want to make a necklace. I want to make it straight, or you can say linear. So since I have used the word identical, so 6 plus 5, 11. Let me write it. 5 plus 6 plus 3, factorial divided by 5 factorial, 6 factorial, 3 factorial. That is the linear arrangement. So 6 plus 5, yeah, 14 factorial. 14 factorial, 5 factorial, 6 factorial, 3 factorial. That is the answer for linear. Okay. And now what about my necklace problem? I have told you now 14 objects are there. So I will say 13 factorial minus 1 na? And divided by 2 also. Why divided by 2? Because necklace 180-degree flipping is allowed. Okay, 13 factorial divided by 2. Rest everything will be same. 5 factorial, 6 factorial, 3 factorial. This is my answer. Yes, if anybody is having any doubt, you can ask me. Otherwise, I will jump to the next slide.
No, sir, it's clear.
Okay, so I will jump now. So now permutation is over. So permutation is completed. Permutation is over now. Okay, all the 3 categories and all, we have done lots of constraints, circular permutation and all these kinds of thing, alternating arrangement, no 2 objects together and so on. We have done lots of questions. Permutation is over. So now we will start combination. So in combination, I have told you no repetition, unlimited repetition and limited repetition. So for no repetition, formula is NCR. For unlimited repetition, formula is n minus 1 plus RCR. And for limited repetition, we will apply generating function. Okay, so let me start these combinations now. Okay, so first question is choose 3 persons from 10 persons for an interview. That is very simple. Choose na. So 10 C3. Okay, from the 10 person, I will choose the 3 persons. That's it. So how you will expand it? 10 into 9 into 8 divided by 3 factorial. 3 into 2 into 1. Okay, so 3 3s are 9. 2 4s are 8. 120 is the answer. 10 C3 is 120. Please take snapshot. I will jump to the next slide.
Done, sir.
Okay. Next is now I will apply some constraints. So 3 person, 3 from 10. I am writing in a shortcut manner just to save the time. 3 from 10 persons and A should always include it. A should always be there. So I have to choose 3 persons. A should always be included. So obviously now I have to choose only 2 persons. From how many persons? 9 persons. So 9C2 is the answer. So simple. So 9C2 will be what? 9 into 8 divided by 2. So 36 is the answer. I think everybody have got it, na? Because person A is already included. So and I want to choose 3 persons. So 1 is already included. So now I have to pick 2 persons. From how many persons? 9 persons. Because A has, yeah, because A is gone now. Yes, so next person A never included. Now if I do not want to include person A, so obviously how many persons are left with me? 9 persons are left with me, and from these 9 I have to pick how many persons? 3 persons, because A should never be included. So what should will be the answer? 9 into 8 into 7 divided by 3. So 3 3s are 9. So 50 yeah, so it will be, oh sorry, yeah, sorry for that. 3 into 2 into 1, 3 factorial na. So 3 3s are 9 and 2 4s are 8. So 12 7 are 84. 84 is the answer. Yes, please take snapshot. I will jump to the next slide.
Done, sir.
Next is A and B always selected. Now I am saying that 2 persons A and B should always be selected. So how you will select them? So obviously how many persons you want to select now? Only 1. Now from how many? 8. So 8C1 is the answer. Answer will be 8 only. A and B always excluded. So I want to exclude A and B both. So how many persons are left? 8. So how many want to choose? 3. So what will be the answer? 8 into 7 into 6 divided by 3 into 2. 56 is the answer. Please take snapshot.
Done, sir.
Okay. So next is set subset kind of thing. So I have told you in starting of permutation combination in the previous class, whenever set subset kind of thing will come, combination will come into the picture, because order does not matter in set and subset kind of thing. So first question is very simple. We have a set, say S. Okay, and 1 2 3 up to 10, total 10 elements are there, and I am asking how many subsets are possible. So how we will answer it, this question? This is very simple scenario. So from these 10, if I choose 0, if I choose no element, that is 10C 0, and it will correspond to which set? That is 5. 5 means what? Set having no element at all. That is possible, na? So one possibility will be from 10C 0. Then I will say 10C 1, because I can choose one element set also. One element subset is possible. Then 2 element, then 3 element, and so on up to 10 elements. So I have told you, na, NC0, NC1, NC2 up to NCN. It was 2 power n, so it will be 2 power 10. I hope you remember in the previous class itself I have told you very beautiful identity, NC0 plus NC1 plus NC2 dot 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 NCN. It comes out to be 2 power n. Why 2 power n? N, this n. So 10C0, 10C1, 10C2, 10C3 up to 10C10, that is 2 power 10. Okay, I think everybody have got it. So answer is 2 power 10. Another way can be by box method also. 1 2 3 4 5 6 7 8 9. Okay, so I will write 1 2 3 4 5 6 7 8 9 and 10. So everywhere I am having two possibility, either present or absent. Every element two possibility, present, absent, present, absent, present, absent. So 2 into 2 into 2, 10 times, it comes out to be 2 power 10 only. Okay, so assume all are absent, assume all are absent, that will be 5. So this is absent, say all are absent except this. So this is present, all are absent, so only 3, and so on. I think you have got it. Okay, so 10C0, 10C1, 10C2, 10C3, and so on, 10C10, that is 2 power 10 only by identity I have told you. And another method is box method. From both method I have told you number of subsets are, if we have 10 element set, the number of subsets are 2 power 10. Okay, and if we make set of this, it will become power set. Anyway, I will tell you this in set theory. I am not going into detail of all these things. Set of all subsets of a set, that is known as power set. I think you already know. Okay, so I will jump to the next slide now.
Okay, sir.
Yes, so yeah, so this is a general rule. General rules is I will solve some questions. So first I am telling you the rule. Size of subset. Whenever size of subset is given to you, you will apply the formula like this, NCR type. And whenever size of subset is not given to you, you will apply the formula n power r type. I'm not going to tell what is n, what is r and all. You will, by common sense, you will get all these things. Okay. Yes. So see this question. Subsets having at least one element. Subset having at least one element. Size is not clear to you. Okay, so let me first explain this thing so that you get more clarity. For example, if I say how many subsets of size 1, you will say 10C1. How many subsets of size 3? 10C3. How many subsets of size 10? 10C10. How many subsets of size 2? 10C2. And this kind of thing. So that's why I have told you the formula that size of subset is given to you, then you will use the formula NCR type. I am using the word na size 2, this size 3, size 1, size 0, size 10, and so on. So NCR type of formula will be applied. But when size is not given to you, then you will apply the formula n power r. For example, if I say subset having at least one element, so size is not clear to you. What is the size? Size can be 1, 2, 3, 4, and so on. So obviously, so this is you can say complementary kind of problem. So 2 power 10 are the total number of subsets possible. From this I will subtract which size, subset having at least one element, na? So that means what? Zero element. Zero element is only one. Only one subset is possible with zero element, that is empty set 5. So 2 power 10 minus 1 is the answer, that is 1023. 2 power 10 is 1024, 2 minus 1, that is 1023. You can think like this also. 2 power 10 minus 10C0. 10C0 is 1 only. So same answer. Why 1? I am answering this thing. Why 1? Because of 10C0. Okay, subset having at least one element is over. Next is at least two elements. At least two elements. Again same kind of problem. Okay, so size is not given to us. So how we will do it? So 2 power 10 total minus at least 2, na? So at least 2 means 0. 0 is not allowed. 1 is also not allowed. 2 is allowed, na? So this is my answer. 2 power 10 minus 10C0 minus 10C1. I think you have got it. So it will be 2 power 10 minus 1 minus 10. So 1024 minus 11023. So 1013 is the answer. Please take snapshot. I will jump to the next slide. If anybody is having any doubt, you can ask me.
No, sir, it's clear.
Okay, I'm jumping now. Next is how many subsets of exactly 3 elements. Now size is given to us exactly 3 elements. Very simple, 10C3. So at most 3 elements. So at most 3 elements, that means size 0, size 1, size 2, size 3. This is my answer. How many subsets include 2 and 3? So now since, please see this, size is not given to you. They are saying these 2 elements should be included. So now box method will come into the picture. So 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. So 1, 2, 3, 4, 5, 6 and so on. So for 2 only one choice. That means it should be included. It should be present. And 3 also it should be present. For rest everywhere 2 choices. Rest everywhere 2 choices. So here 1, rest everywhere 2 choices. So 2 power 8 is the answer. Okay, why? Because 2 will be gone. No? So 2 into 2 into 2, 8 times will be there. 2 power 8 is the answer. I hope I have made the point clear. So next is exclude 2 and 3. Exclude 2 and 3 means what? In place of present you will apply absent. So only one choice. Again same thing. Okay, so again answer will be 2 power 8. If anybody is having any doubt, let me copy it. No problem, I will copy it. So now what I will write here, I will put this present as absent. So only one possibility, absent. So 2 into 2 into 2, that is 2 power 8 is the answer. Again same. Okay, so next is include 2 and 3, exclude 4. So I think you have got it. It's wastage of time. 2 power 7 is the answer. Because for 2 only one choice, that is present. 3 only one choice, that is present. 4 only one choice, that is absent. For rest everywhere 2 possibilities. So total 7. So 2 power 7 is the answer. Okay, so I hope everything is fit and fine. Please take snapshot and look. Okay, yes, now everything is on one slide.
Done, sir.
Okay, now. Next is 5 element subsets. So obviously 10C5 size is given. Na? 5 element subset include 2 and 3. 5 element subset, it should include 2 and 3. So obviously 5 element we want and 2 and 3 should be included. So only 3 we want. From how many? 10. Okay. So from the 10 I will pick 3 because 2 is already included. Okay, oh sorry, 2 and 3 are included na, so 2 and 3 are gone. So from 8 I will pick 3. 8C3 is the answer. Okay, again I'm repeating 5 element subset including 2 and 3. So 2 and 3 are included, so obviously 3 we have to choose, but from how many elements? Only 8 elements because 2 and 3 are gone now. Okay, from 8 I have to pick. Yes, next exclude 2 and 3, 5 element subset. Same. I think we should not waste time here. Since we want to exclude now. Okay, same kind of thing we have to apply. We want to exclude. That means what? 2 and 3 should not be there. So obviously, how many elements we have to pick? 5 elements we have to pick. But from how many? 8. So 8C5 is the answer. Okay, similar scenario, similar kind of thing only. Okay, I have explained you a few slides back these kind of things. Like from 10 persons we want to choose 3 and all. We have done it. Okay,
Yes, sir.
so yeah, 2 and 3 included, 4 is excluded. So 5 element subset we want to make. 2 and 3 should be included, 4 should be excluded. So how many elements now we have to pick? Because two elements are there, so I have to pick 3 elements. Okay, I have to pick 3 elements, but from how many? 2 and 3 and 4 are gone, so 7 are left. So 7C3 is the answer. Okay, please take snapshot. I will jump to the next slide.
Done, sir.
Okay, So next type of question is, see, we have 5 boys and 6 girls appear for an interview. We want to select 5 candidates such that 3 should be boys and 2 should be girls. So now I am applying constraints. Okay, so 5 boys and 6 girls appear for an interview. So we want to select 5 candidates, and from these 5 candidates 3 should be boys and 2 should be girls. So first of all, you should make a figure like this. Please let me draw the figure and then I will explain. 6 plus 5, how many total candidates are there? 11 candidates are there. From these 11 candidates, how many are boys, how many are girls? 5 are boys, 6 are girls. Now from these 11 candidates, how many candidates you want to pick? 5 you want to pick. And from these 5, how many are boys? 3 are boys and 2 are girls. So answer will be very simple. You will say 5C3 multiplied by 6C2, like this. So every time if this type of question come into the exam, you will make figure like this, and from figure you will answer the question 5C3 into 6C2. Okay, so from 5 boys you want to pick 3 boys. Simply you can say like this: from 5 boys you can pick 3 boys. So 5C3. From 6 girls you want to pick 2 girls. 6C2. That is the answer. But why I have made this figure? Okay, you will get it after few slides. But it's my kind suggestion. Please make this figure. So 6 plus 5, that is 11. From 11 I want to pick 5. Okay, and what are the ways? From 11, 5 boys and 6 girls. From 5 boys you want to pick 3 boys. From 6 girls you want to pick 2 girls. Answer is this. Very, very simple answer. But why I have made this figure? You will get it after few slides. Please take snapshot.
Done, sir.
Okay. Next is at least three boys. Okay, at least 3 boys should be there. So same question. I have just applied constraint on it, that at least 3 boys should be there. In here I have exactly 3 boys, but now I am saying at least 3 boys. So what are the ways? So I will say first 11 candidates are there. From the 11 candidates we have 5 boys and we have 6 girls. Sorry, 6 girls and 5 boys. 6 plus 5 is 11. You should sum like this: 5 boys, 6 girls. So 5 plus 6 is 11. Okay, and how many we want to pick? 5 we want to pick. Now what are the ways? What I am saying is at least 3 boys. So 3 boys and 2 girls you can take. Okay, because we want to pick 5. Now same. Why 5? It is given in the question itself. Okay, same question, just I have replaced this 3 boys by at least 3 boys. So 5 candidates I want to pick. So at least 3 boys now. So if I take 3 boys, then I have to take 2 girls. Sum should be 5. That's why I have drawn this figure, so that you get more clarity. 3 plus 2, 5. Okay. Or 4 boys, 1 girl. Or 5 boys, 0 girl. So these are the 3 possibility. So how we will do it? I will simply say like this: from 5 you pick 3. 5C3. Work is not yet over. I have to pick girls also. So 6C2. Work is over now. So that's why I will apply OR. That means plus. So 5C4 into 6C1 or 5C5 into 6C0. Okay, so this is very simple. 5C5 is 1, 6C0 is also 1. So only one way, na, you pick all the 5 boys. That is this thing. 5 boys and 0 girls means only one way. That is pick all the boys. That's it. Okay, this was the way for at least 3 boys. Next is at least 1 boy. How you will do for at least 1 boy? So now it will be a difficult kind of thing for you for at least 1 boy, because there will be many cases. Okay, at least 1 boy means what? 1 boy, 4 girls, 2 boys, 3 girls, and so on. Okay, so there will be many cases. So better is do by complementary method. Complementary. Complementary means, let me draw the figure again here. So from the 11, you want to take 5 boys and 6 girls, and you want to pick from 11. We how 11? 5 boys are there, 6 girls are there, and I want to pick 5 persons. Okay, or 5 candidates we want to pick. Okay, and what are the ways? So at least 1 boy, na? So you take 0 boys. 0 boys, you will take 5 girls. Okay, so how many ways? 5C0 multiplied by 6C5. These are the ways to pick 0 boys and you can say 5 girls. Okay, yes. So this is the way for what for complement of this. Okay, so from which I will subtract. Now things will be, you can say, a bit complex for you. So better is that, that's why I have drawn this figure and all. Okay, so total how many will be there? Total possibilities will be what? So from 11 candidates you can pick 5. So 11C5 minus this is my answer. Please try to focus here. That's why I have drawn this figure. 11C5. Why 11C5? This thing I am taking 11C5. Okay. So from 11C5, this thing if I subtract, finally I will get at least one boy. So 11C5 means what? 5 means from 11 you can pick any 5 candidates, any 5. These 5 can be whatever way you want. All the 5 boys, all the 5 girls, 2 boys, 3 girls, 1 boy, 4 girls, and so on. All the possibilities are covered in 11C5. That's why from the total I will subtract this thing. Finally, what I will get? At least one boy. Yes, so please take snapshot. I will jump to the next slide. So this is the much better way to do. That's why I have drawn the figure, and so that you get more clarity that okay, I have to pick this branch. For complementary problem, I have to pick this branch 11C5 like this. Please take snapshot. I will jump to the next. Yeah, done?
Yes, sir. Yes, sir. Done.
Okay, next. Next is at most 4 boys. Again, complementary problem. At most 4 boys means what? 0 boy or 5 girls, 1 boy, 4 girl, 2 boy, 3 girls, 3 boys, 2 girls, and 4 boy, 1 girl. At most 4. So how many choices? I think 5 choices will be there. I think I should not write them because it will simply waste our time. I think you have got it. So better is complementary problem. Okay, so anyway, I have to draw the figure. 11. 5 boys are there. 6 girls are there. And I want to pick 5. Okay, so possibilities are this: 0 boys, 5 girl. Let me write it. Boy, girl. 0, 5. 1, 4. 2, 3. 3, 2. 1. Sorry, 3, 2, 4, 1. So you should write like this: 0, 1, 2, 3, 4, 5, 4, 3, 2, 1, like this. But these are many cases. We have to add them, and it will create hell lot of problem for us. So we should not do like this. Okay. So what is the better way? Complementary method. So what is the complementary method? I have told you. You will consider this branch. So 11C5 minus what? At most 4 boys, na? So you take 5 boys. If I take 5 boys, what will be the way? 5C5 multiplied by 6C0. Why 6C0? Because obviously we will not take any girl, na? When all the 5 boys are taken, we will not take any girl because 5 we have to pick. So this is my answer. 11C5 minus 5C5. That is 1 only. So 11C5 minus 1 is the answer. Okay, now please take snapshot. I will jump to the next slide.
Done, sir.
Okay. Next is at least 2 boys and at most 2 girls. So for such kind of problem, you will get confused in GATE exam. At least 2, at most 2, and so on. So you apply one constraint, and then accordingly you will cut other things. So 11. So 5 boys, 6 girls, and you want to pick 5. So you apply one constraint. At least 2 boys I am applying. So here boys and here girls. So 2 boys, then 3 girls. At least 2, na? So then 3 boys and then 2 girls. 4 boys, 1 girl. 5 boys, 0 girl. So once I have applied at least 2 boys, now concentrate on at most 2 girls. At now, because there is and here, so this thing will be gone. Why? Because I have said at most 2 girls. So how you have taken 3 girls? This is gone. Rest everything is fit and fine. So these 3 cases we will consider and we will get the answer. So if I want to write for these 3 cases, 5C3 multiplied by 6C2 or 5C4 multiplied by 6C1 or 5C5 multiplied by 6C0. This is my answer to this question. Okay, so there should be no confusion at all. So if you keep on applying both the constraints, obviously you can apply them, but some students might get confused. So better way is apply one constraint, and at least is very easy. At least 2 means what? You should start from 2 and go till 5. Okay, and apply like this here because 5 was there now, so that's why I apply this easily. And then because at most 2, so you will cut the other choices and all. This is one of the best way to solve this question. Let me jump to the next slide now. Please take snapshot. Okay. Next is a question paper consists of 50 questions consisting of 2 parts, 25 questions each. Okay, but for 50 questions, a question paper has 50 questions and it has 2 parts, 25 questions each. Part 1, part 2, part 1 has 25 questions, part 2 has 25 questions. Student has to answer 10 questions. Okay, so student has to answer only 10 questions. So there are lots of choices. Okay, from 50, it has to attend, he has to attend only 10 questions, such that at least 6 questions from part 1 and at most 3 questions from part 2. So how many ways? That is the question. Let me write it. How many ways? How many ways? Same type of question. So I will draw the figure first. 50 questions, part 1, part 2, 25, 25 each. So now student has to answer how many questions? 10 questions. So from the part 1, he has to answer at least 6 questions and at most 3 from part 2. At least 6 from part 1 and at most 3 from part 2. Okay, so again, so 2 constraints, so apply 1 constraint, then we will solve it. At least 6 na. So here 6, then 4 because of 10 here. That's why I am drawing the figure. Now you will get very much clarity in GATE exam, and nobody will get confused here. So you should add them. 6 for 4, 10. Okay, I am doing great thing. That means I am doing perfectly all the things. Next is you will recheck all these things. 7, 3, then 8, 2, 9, 1, 10, 0. 1 constraint I have applied, at least 6 questions. Now at most 3 questions from part 2. At most 3. So I will cut it. This is gone. So rest I have to do it. So what are the ways? So from 25, from 25 I will pick 7. So 25C7 multiplied by 25C3. Or because this is over, so after picking 5, sorry, 25C7. 25C7, after choosing 7 questions, my work is not yet over. I have to attempt part 2 questions also, 3 questions from part 2. So this is the way. Or next is 25C8, 25C2, or 25C9 multiplied by 25C1, or 25C10 multiplied by 25C0. This is my final answer. Add them, you will get the answer. Okay, so let me put everything on one slide. You can take snapshot. I will jump to the next slide now.
Done, sir.
Okay, so this figure is very important for such questions. Okay, yeah, let's now we will start some playing cards question. 52 cards, 5 cards are picked, and we need exactly 2 kings. So how you will do it? So from 52 cards, I want to pick 5 cards, but the condition is that from these 5 cards, we should have at exactly 2 kings. So how we will do? So I will say 52 cards are there. So 52 cards, so 4 are the king and 48 are non-kings. 4 are king, 48 are not king, and I want to pick 5 cards, and 2 should be kings and rest 3 should be non-king. So very simple. So 4C2 multiplied by 48C3. I think everybody have got it. Please take snapshot. I will jump to the next slide.
Done, sir.
Okay. Next is 5 cards chosen, 2 king and 3 queens. Okay, 5 cards we have to choose from 52 cards. So and 2 kings and 3 queens. So how? First of all, please try to focus at how you will make the diagram. 52. 52 cards are there. So how many kings are there? 4 kings. How many queens are there? 4 queens are there. But we will not stop here. I will say like this also. So how many are remaining? 52 minus 8, 48, 44. 44 are neither king nor queen. Okay. So now we want to choose 2 and how many we want to pick? So we want to pick 5 cards. So 2 should be kings and 3 should be queens. Okay, so how many non-king, non-queens? 0. Okay, why I am building this thing? You will get more clarity in the next question. Okay, please bear with me for 2-3 minutes. I have started the class late. Please, I know 1 minute is still over. Okay,
Not a problem, sir.
22. No problem. Yes, it's really good now. Okay, so please bear with me for 2-3 minutes only. 4 king, 4 queen, and 44 non-queen and non-queens. So what will be the answer? From 4 king, I have to pick 2. For 4 queens, I have to pick 3. Okay, and from 44 non-king, non-queen, I have to pick 0. This is very, very important. Please try to focus. This is very, very important. Many of you will skip it. Of course, it will not affect our answer, but still we have to do this kind of thing, because in other questions we will get confusion. So while making figure, you should consider this thing 52. So sum of these 3 should be 52 now. I'm getting it. So if I do not consider this branch, then sum is 8. It is not 52. So I have to consider this branch also. So 44 non-king, non-queen. Okay. So what will be the answer? Answer is very simple. 4C2 into 4C3. Okay, and multiplied by 44C0. 4C2. Okay, so king we have taken, but our work is not yet over. So multiply 3 queens. Our work is not yet over. We will pick 0 card from the non-king, non-queen category. That is 44C0. This is my final answer. Please take snapshot. I will jump to the next slide.
Done, sir.
Okay. Next is 5 cards, 2 king and 2 queen. That will create very big problem. So now we want to pick 5 cards, and out of which 2 kings and 2 queens. So how you will do it? 52 cards, 4 king, 4 queens, 44 non-king, non-queen. And how many I want to pick? 5. 2 here, 2 here. If you do like this, obviously your game is over, because you have done it wrong. Because see this, that is the basic aim of figure. Now 2 plus 2 is 4. It is not 5. So 1 is left. So I will say 1 here. So now we will do it. So 4C2 multiplied by 4C2 multiplied by 44C1. This is my answer. So now obviously it will affect our answer. Earlier it was not affecting, because 44C0 is 1 only. No problem. Multiply by 1 will not create problem. But here multiply by 44 will create a huge gap. Okay. So this is my answer. Okay. So next is other kind of problem. We will consider them in the next class. Please take snapshot of this. Yes,
Done, sir.
and okay, and take this as homework. Try to do it in homework. These are very simple scenarios. So for
Okay, sir.
constraints I have applied. Okay, so 11 persons. I have to pick 5 persons. From 11 persons, 5 boys and 6 girls. So from 5 boys, I have to pick 3 boys. From 6 girls, I have to pick 2 girls. I have made the figure, and I am applying constraints like boy A should be included. Next is boy A and girl B should be included. Boy A should be excluded. Boy A and girl B should be excluded. Boy A and girl B should never be present together. These 5 questions, try to answer them as homework, and I will start from here itself in the next class.
Okay, sir.
Okay then. Thank you so much. Bye bye. Good night.
Good night, sir.